talk to Sir Isaac Newton?
Yes!
Let's make a connection then.
Hello, everyone. Do you have questions for me? I'm always ready to help.
Mr. Newton, could you tell me how to use Neuton to create an AI solution?
Absolutely. Let me show you how easy it is to create an AI solution with Neuton.
Hello everyone. John Wickens, Sir Newton's assistant, is here. I will take over now. Neuton AutoML is a SaaS platform, based on Newton's neural network framework, that automates the whole process of machine learning through the use of innovative and cutting-edge technology. The Neuton platform enables users to utilize the system to predict various outcomes based on historical data. This is made possible by processing the user data and applying it to train a machine learning model. During training, the model is looking for patterns and dependencies between the input data to make the right predictions. After the model has been trained, the user can then utilize the model to make predictions on new data via various options provided by the platform. The full machine learning workflow and pipeline consists of 3 simple steps. The first step, select data for training. The second, train your model. And the third, make predictions. Neuton's interface is simple and clear, so users with or without a data science background can use it. Neuton currently allows users to solve 2 types of problems: classification and regression. Classification is the prediction of a class among a given set of classes. There can be 2 or many classes. For example, for the Titanic dataset, one might predict which passengers survived the disaster and which didn't. Regression is when one tries to make a prediction of a numerical or continuous value, thereby outputting a quantity. For example, for the Boston housing dataset, one might predict the pricing of houses given features like location, size, number of bedrooms, etc. Let's create a model to solve a classification problem for the preloaded dataset, Titanic. You'll want to begin by adding a solution. A solution is an object allowing the user to build a model and make predictions by uploading new data. All workflow actions are executed inside the solution. On the starting page, My Solutions, click Add Solution. Add Solution is the only option available when you log in for the first time. Specify a solution name, for example Titanic Prediction. And describe it as, prediction of which Titanic passengers survived the disaster, based on passenger data, name, age, sex, etc. And click Next. After you have named a solution, you will be redirected to the Dataset tab. Here you can specify the dataset that will be used for model training. Datasets with historical data are usually referred to as training datasets. Click Select to choose a dataset for training. You have the following options. The first option is Upload Dataset. This tab allows you to upload your own dataset. The second option is to select existing dataset. Here you can select one of your previously loaded datasets. And the third option, Preloaded Dataset. Neuton provides popular preloaded datasets for demonstration and testing purposes. Neuton uses training datasets to learn to make predictions. Predicted outcomes are often referred to as the target variables, or targets. To learn more about a particular dataset, click the question mark icon near the dataset name. In the tooltip, you can find the task description, target variable, and target metric. Let's look at the preloaded historic training dataset, Titanic. Click the lens icon. When you do, you can see the dataset in a pop-up window. It is a dataset with statistics of Titanic passengers from the Kaggle Titanic ML competition. The dataset contains data of the real Titanic passengers. Each row represents one person. The columns describe different attributes about the person, including if they survived or not, their age, their ticket class, their sex, the fare they paid, and others. In this dataset, the passengers that survived the disaster are labeled with 1, and the passengers that did not are labeled with 0 in the survived column. As the target variable survived has two values, 0 or 1, it is a binary classification problem. Independent features, like passenger ticket class and P-class column, name, sex, age, cabin class, and others, are characteristics that are analyzed to predict the target variable. Looking at various features, you may conclude that, for example, children or women had a greater chance of survival, and you may validate your hypothesis on this dataset. In this particular case, Neuton's AutoML will draw similar conclusions from the patterns in the data and validate them. Neuton will consider many more factors, not only sex and age, and will make predictions with the highest accuracy. Now go ahead and close the pop-up window. Let's open our dataset and do a quick review in a text editor. I will use Notepad++. You can use any text editor, available for your operating system. I will open my local copy of the Titanic training dataset. To train the model and predict with it, you must prepare your dataset for Neuton, according to these simple requirements. The first rule. It must be a CSV file with UTF-8 encoding and with, at minimum, 2 columns and 50 rows. The second rule. The first row must contain column names, and a comma, semicolon, pipe, caret or tab must be used as a separator. The third rule. Neuton currently supports only the English US locale, for timestamps and numbers, so you must use a dot as a decimal separator, and delete commas, typically used to separate every third digit in your numeric fields. And the fourth rule. Text fields should start and end with quotes, in order to avoid confusing symbols in the text, with column separators. Neuton supports NLP, but can currently only process textual fields in US English. If you used a language different from English, for categorical fields in your dataset, you must transliterate them into US English. Neuton automatically checks your dataset when you upload it. If the dataset does not meet the requirements, you will get an error message about an invalid data format. You should then recheck your dataset and upload it again. In case of incorrect dataset formatting, Neuton won't be able to build an accurate model. Let's upload the local copy of the Titanic training dataset. And click OK. Now you can select the target variable that Neuton will predict. For the Titanic dataset, it is survived. By default, the base mode is selected and provides a fully automated experience. However, for the purpose of briefly exploring advanced mode options, let's switch to advanced mode in the top right corner. While in advanced mode, you can specify the validation dataset if necessary. The validation dataset is another subset of the input data. It is used to validate the model during training. It measures the error between the known target values in the validation dataset and the predicted values for the dataset in question. The validation dataset must have the same structure as the training dataset, otherwise it is impossible to use it for validation. While in advanced mode, you can also delete some independent features, if you consider them to be unnecessary for model building. A model is a mathematical representation of dependencies between the features and the target variable. Neuton can build such models perfectly. Let's say, for example, you consider ticket to be unnecessary, because you don't believe ticket number influenced whether a passenger survived or not. For the purpose of our walkthrough, I will not delete any features, and will rely on Neuton's automatic algorithm. Let's now switch back to the base mode. Click Next and you will be redirected to the Training tab. On the Training tab, Neuton has automatically detected task type as binary classification and target metric as accuracy for the Titanic dataset. Metrics are used to show a model quality. For example, accuracy shows the proportion of true results among the total number of predicted results. Metrics are calculated by comparing predicted values with real values in the validation dataset. Neuton uses the metric value to build a model of the highest quality. For a classification task type, a model that has correctly classified 7 samples out of 10 has a model accuracy equals to 0.7. The closer to 1 the value is, the better. There are many different types of metrics. For example, Neuton can also detect regression task type and set the default metric as root mean squared error. For more information about metrics, please refer to the metrics definition for any given task type in the support library. Now let's switch to advanced mode again, to review the training settings. Here, you can see the following parameters. The maximum training duration parameter limits the maximum model training time in minutes. The default value is 2880 minutes. Training duration is unique for every dataset, and depends on the quality of data in the dataset, task type, and selected target metric. The next parameter is the maximum number of coefficients. This parameter limits the size of the model and the required number of operations necessary for predicting with the model. By default, the number of coefficients is unlimited. The perform data preprocessing parameter enables automatic data preprocessing. To build a model, raw data must be transformed to a machine learning feasible format. Neuton has the ability to perform this automatically. With this option enabled, you may upload datasets with different data types, such as textual data, dates, categorical variables and string representation, and others. Neuton will then populate any empty feature value with automatically calculated value. Data preprocessing is enabled by default. The following parameter is perform feature engineering. This parameter enables actions that extract additional information and create new variables from the existing data. These automatic actions can improve the model quality. For example, Neuton can combine age with ticket class using advanced calculations, and consider the result as a new feature during model training for the Titanic dataset. For every dataset, the combination of features is unique. Feature engineering is disabled by default. Below the data preprocessing and feature engineering parameters, you will see the time series menu. Time series problems arise from time dependencies in the data. For example, data consist of sales values by day for the past year, and you want to predict sales for the upcoming month. To consider a problem as a time series, the data must incorporate the following conditions. The first condition: the dataset must include a date and time column. The second: the target variable must be dependent on the date and time. And the third: you want to predict some events in the future. If all these conditions are met, you should enable time series on the platform. And in the time series menu, you should specify field containing date and time, as well as number of periods to predict, and gap between the training data and the prediction window. For our purposes, I will leave all of these parameters unchanged. Let's switch back again to base mode now. And let's start training. After the training is initiated, you can monitor the training process in the progress bar and in the model status area. After some minutes, the Analytics Tools button will be activated. Let's click Exploratory Data Analysis in the Analytics Tools menu. The ADA tool automates data analysis and highlights the important statistics in the context of a single variable, overall data, interconnections, and in relation to the target variable. You can see following sections. Dataset Overview. This section displays brief data statistics of your training dataset and provides following information: problem type, dataset dimension, missing values, records number, etc. The second section is continuous data distribution and relation to the target variable. The third section describes discrete data distribution and relation to the target variable. And other sections with information about target data, correlations, missing data, and outliers. For every dataset, the set of graphs is individual. Once you have seen, the model is consistent in the status bar. You can stop training anytime if you are satisfied with the model quality, as represented by the current target metric. You can also opt to continue training again at any time to get a more precise model. Training will be continued from the same point where it was previously stopped, thus saving time and infrastructure costs. Now that we see the model training is complete, it is time to predict a target variable on new data. Once training is complete, you will be automatically redirected to the Predictions tab. Let me first show you some of the metrics you will find on the metrics list. Besides the target metric, Neuton calculates additional metrics for each task type. For binary classification, for example, you can find the area under the curve, logarithmic loss, Gini coefficient, and more. In addition, you can find the confusion matrix. Also known as an error matrix, this is a specific table layout that allows visualization of the performance of the algorithm. Each row of the matrix represents the samples in a predicted class. Each column represents the samples in an actual class. The matrix makes it easy to see if the system is confusing two classes. To read more about metrics, please refer to the support library. Now, I'd like to show you the model feature importance matrix. After the model has been trained, the platform displays a chart with the 10 most significant features. In other words, the 10 features that had the most impact on the model prediction of the target variable. In the features column, you can see the names of the features. In the rank column, you can see their importance on model prediction. And on the bar chart, you can see the normalized importance value. You can select features to display using the Add Features button. Using checkboxes, you can unselect irrelevant classes to hide them. Let's return to the Prediction tab. If you want to use the Neuton model via the web interface without coding, click Enable Predictions. Let's wait a moment while prediction is being enabled. Excellent. Web predictions are available now. Let's look at how to use the web interface to make predictions without any coding. Click Start to begin. You should specify the dataset you will use to make the predictions. This dataset is a CSV file which must have the same structure as the training dataset, except there should be no target variable. For our purposes, I will use the trained model to predict the target variable values for the preloaded dataset Titanic. I drag and drop the test dataset with new data. The test dataset for this example can be downloaded from the Kaggle Titanic ML competition website. You'll probably notice that the interface is similar to that of training dataset selection. If the dataset used for predictions has a different structure than that required, you will receive an error message that the data is not valid. Let's look at the test dataset. You can see that it has the same structure as the training dataset, but there is no target variable, survived. Later in the web interface we can see the predicted class for the target variable. Close the window and click Start. Prediction may take a few minutes. You'll be notified by a pop-up window with a message when the prediction is complete. The prediction has been completed. You can click the Download button. A file with prediction results will be downloaded. Let's click the View button in the pop-up window. You can now see the predicted values in the first column. These values are predicted values for the target variable survived. And in the probability of 0 and probability of 1 columns, you can see additional information, the probability of a predicted value. For prediction results relating to the regression task type, you will see the confidence interval and confidence probability. The confidence interval shows the possible prediction spread, for each predicted value, with calculated probability. Let's click the Model Interpreter button to activate this tool. It allows users to interactively change original feature values to see how the prediction results change. Features are ordered according to their rank in the feature importance matrix. The numeric features are represented as area charts. The feature values on the horizontal axis are ordered from minimum to maximum. For each numeric feature value you can see the corresponding prediction value. You can also see the feature influence on the prediction result. A positive feature influence value means the predicted target value will increase when the feature value is increased. A negative feature influence value means the predicted target value will decrease if the feature value is decreased. The categorical features are represented as bar charts. On the horizontal axis you can select any feature value. For the classification task type you can see the predicted class along with the probability. For all features, hovering over any feature value will show you the corresponding prediction details. Also, for any feature, if you left-click and move the pointer to the desired feature value, and release the left mouse button, the prediction result will be recalculated given the new feature input. You can click the Return button to return to the original feature value. Using the slider you can specify the threshold value of the target variable, and Neuton will highlight the corresponding values of the original features for which the prediction result is above or below the threshold value. For the classification task input, the minimal probability of the predicted class is used as a threshold. This way you can quickly see which feature values you need as input to predict above the selected threshold. Now you know with a high level of confidence which passengers survived the disaster and which, unfortunately, didn't. Congratulations! You have now learned the full Neuton AutoML workflow, from dataset uploading to prediction stage, and can easily solve any classification or regression task with Neuton. For more advanced users with skills in programming, stick around to learn how you can use a hosted model to augment your own application with AI capabilities, and how to use a trained model without Neuton. In this video, I will show you how to use a Neuton-hosted model with REST API. Say for example, you have developed your own application, which you would like to augment with Neuton AI capabilities, by sending prediction requests to the Neuton platform. On the Prediction tab, click Access Instructions when prediction is enabled. In the resulting pop-up window, you will find instructions on how to send a request for prediction of a single line or a whole file. You will also see possible return statuses, and get a request for prediction results. Further below in the same pop-up window, you will find code samples for different programming languages including Scala, C#, Java and Python. Let's consider an example for Python. First, to run Python scripts, you must have Python 3 installed on your computer. I will use Spider to edit and run Python scripts. Spider is an integrated development environment for Python. Let's go ahead and click Python to download a code example. Unpack the downloaded archive and open the python sample.py in Spider. In the script you should specify two arguments for the send request function. The first argument is a URL in row number 6. Copy-paste the URL from the access instructions, which is equal to the URL address of the hosted model before the fourth slash, but not including it. The second parameter in row number 7 is the path to test the dataset, which I downloaded from Kaggle. I will specify the name of the file as test.csv. And copy-paste the file to the same folder, where my script is located. You can choose to specify a full path to the file, if you prefer. In samples we give for other programming languages, you should specify the same parameters, the URL to hosted model, and path to the test dataset. Now we can run the script. The script results will be saved to the folder where python sample.py was run, and will have the same structure as you saw during prediction in the web interface. Over the next few minutes, I will walk you through how to use a trained model without Neuton. On the Prediction tab, click the Download button. Then select your operating system, for example, Windows. The archive will be downloaded. Unzip the archive, and open the folder. Because my Titanic prediction has a binary classification task type, I will run classification example.py, a script to predict on new data without Neuton. In case of regression task type, you should run regression example.py. For more information about archive structure, please refer to Neuton User Guide in the support library. Let's go ahead and open classification example.py in Spider. In classification example.py you should specify the path to the dataset, for which you wish to make the predictions. My test dataset is named test.csv. I will copy-paste the test dataset for which I will make the predictions, to the same folder where classification example.py is located. In my case, I will leave the file name test.csv unchanged, in classification example.py, but you can specify the full path to your file, if desired. Now I can run classification example.py. My output will be saved in an automatically created folder. The resulting file name is test with predictions.csv. The file structure is the same as seen previously in the web interface. You can see the predicted values for the target variable survived in the first column. And in the probability of 0 and probability of 1 columns, you can see the probability of the predicted values. Congratulations! You have now learned how you can use a hosted model to augment your own application with AI capabilities, and how to use a trained model without Neuton. In this video I will show you how to use Postman for prediction via REST API of the Neuton platform. Postman is a software for API development, testing and debugging. Before using Postman for predictions you must train your model and enable web prediction for your solution. You have two options for sending prediction requests in Postman. The first option is to send the formed data in JSON format. And the second option is to send the whole file for prediction. Let's review the 5 steps to predict on CSV file. I will use the Titanic test dataset from Kaggle for this example. Step 1. Copy the second URL from the access instructions for files. You will use this URL in the Postman request URL specification. Step 2. Open the Postman application, and on the New tab select Post Request Type. Then select Body. Click the Form Data Radio button. Type File in the key field. Check the box. Then navigate to the file with new data using the Select Files button in the Value field. Now, paste the URL from Step 1 in the Request URL, and click the Send button. Step 3. Copy the returned UUID. Step 4. Open a new Postman tab. To view the data processing status returned by Neuton Platform, paste the URL from Step 1 in Request URL. Replace the file with the status UUID at the end of URL, and click Send. Neuton should return with the status Success. Step 5. To get the prediction results, open a new tab in Postman. Paste the URL from Step 1. Replace file with the result UUID at the end of the request URL. And click Send. You will see the prediction results for the whole file. You can see the predicted values for the target variable survived in the first field, and in the probability of 0 and probability of 1 fields, you can see the probability of the predicted values.
Thank you for using Intelligent Agent.